We'll just finish up with a couple of exercises that people might do to check their understanding of this lecture. This one is a note from the book where it talks about using these techniques to enumerate what's called a super necklace, which is a labeled cycle of cycles. And you can look in the book for a definition of that and see how the symbolic transfer gives this generating function. And the problem is to show that that's asymptotic to 1 over n times 1 minus 1 over e to the minus n. And there's a hint, take derivatives. So that's, we'll do lots more applications of the meromorphic transfer theorem later on, and this is just an exercise on a different kind of combinatorial object. Again, the best thing to do, particularly for people without much familiarity with complex analysis, is to review the lecture and the lecture notes, and also to look at the book in the section on complex analysis. As usual, there's much more in the book than I have a chance to talk about in lecture, so your best strategy for now is to try to get a feeling for what's there and pursue what you find interesting. But you're not going to be able to understand every detail without putting in many hours. Our goal is to give you some familiarity with the major concepts and give you a place to research later on when you discover problems that analytic combinatorics might be effective for. And go ahead and write up a solution to that note. And then also I'd urge people to do these simple programming exercises just to connect the abstractions that I've talked about a little bit closer to the real world. So one thing you can do is compute the percentage of permutations, say, that have no singleton or doubleton cycles. And you can make a recurrence to go ahead and compute that, and then compare it with the asymptotic estimate that we get from analytic combinatorics, say for n equals 10 and 20. Another thing you do is get my code on the book site for plotting complex numbers on a grayscale image according to the absolute value, and plot the function associated with that super necklace, just or plot some other function that you find interesting, just to see how easy it is to create these kinds of images, because we're going to be using them to gain intuition about the kind of functions that we talk about later on. Again, next time we'll look at lots and lots more applications of this basic transfer theorem.